morning. Today our group will present on driven and cast impressed parts, commonly known as the Franki parts. Franki parts is a deep foundation system used when high load-bearing capacity is required. This piling system is suitable for projects where the load-bearing soil layer is located deep below the ground surface. The pile is constructed by driving a steel casing into the ground and then casting concrete in place to form a strong and durable foundations. Franki piles are widely used in heavy structures such as bridge, industrial buildings, and wind turbine foundations because they can safely transfer large structural loads to deeper and stronger soil strata. Therefore, this system is considered an efficient and reliable solution for challenging ground conditions.
Okay, now I will explain the purpose of Franki bar. The main purpose of Franki bar is to support heavy structures safely. It is used when the ground is weak and cannot carry the building by itself. The Franki bar transfers the building load to deeper and stronger soil or rock. This helps make the foundation stronger and more stable. As you can see, Franki bars are used in many types of buildings. For residential projects, they are used for high-rise apartments. For commercial projects, they are used in offices, shopping malls, and hotels. For industrial projects, they are used for factories and power plants because these buildings carry a very heavy loads. Next, I will explain the function of Franki bar. The first function is to carry heavy structural load safely. Second, it transfers the load from the building to deeper and stronger or rock. This prevents the building from sinking. Another function is to reduce settlement of building so the structures stay level and safe. The Franki bar also improve the stability of the foundation. During installation, it compacts the surrounding soil. This makes the soil stronger and increases the pile's load capacity. Finally, the Franki bar provides a long-term structural performance and safety. It helps the building remain strong and stable for many years. So, the Franki bar is a reliable foundation system for heavy construction projects.
For this slide, I will talk about the method construction of Franki bars. For step 1, the picture shows a steel casing is positioned vertically at the pile locations. For step 2, a dry concrete pile is placed at the bottom of the casings to prevent soil and water from entering. Next, for the step 3, the video shows that the hammer repeatedly strikes the concrete block, causing the casings to penetrate into the ground. For the step 4, upon reaching the required depth, the plug is expanded to create an enlarged base that increases the load-bearing capacity. Other than that, the video at step 5 shows the reinforcement cage is installed inside the casings. Next, for step 6, concrete is then poured into the casings to form the pile shaft. For the step 7, finally the casing is gradually withdrawn while concreting continues producing a complete Franki bars. But for step 8 shows the picture that a complete Franki bars that transfer structural load safely to deeper soil strata.
Next is advantages of the construction method. Firstly, it is economically viable. meaning the adaptation of various designs to suit soil types and construction location. It is enabled to maximum usage with regard to load-bearing capacity and pile length. Secondly, it has low noise emission, meaning it constructed on site with the help of using casing tube, hammer and crane. This method does not produce any noise and pile. It is constructed safely with no damage. Thirdly, it is good resistance to settlement. It features a wide base at the bottom that thoroughly compacts the contacting soil to increase overall beam capacity and reduce chances of settlement. The fourth is environment friendly. Environment friendly meaning it is made on site by pushing the soil aside instead of digging it out. This method produces no waste or emissions, making it very safe to use in polluted areas. Lastly is gravel pre-compaction. If native soil lacks sufficient load-bearing capacity at desired depth, on-site soil improvement is achieved by bounding gravel both above and below the intended pile casing depth before ramming the pile to its final target depth.
Next, let's look at the major disadvantages of the Franki pile construction method. First, there is severe noise and vibration. The heavy internal drop hammer generates intense ground shockwave and loud impacts. Because of the high risk of causing structural crack or settlement to neighboring properties, this method is often completely unusable in dense urban areas. Second, we face a high risk of the necking and hidden defects. As the steel casing is pulled up and the concrete is rammed underground, soft or squeezing clay soil can easily push inward. This chokes the fresh concrete shaft, creating hidden structural weak points that cannot be visually inspected after pouring. Third, ground heave and soil displacement present serious risks. Driving this heavy casing force huge volume of soil outward and upward. This lateral movement can easily lift, shift, or crack adjacent newly poured green piles or nearby retaining walls. Finally, there is a high economic cost. Franki piles require highly specialized heavy piling rings, temporary driving casing, and expert labor. Consequently, they carry a much higher financial premium compared to standard precast reinforced concrete piles. In summary, the driven and cast-in pile Franki pile is a highly effective deep foundation system designed to safely support heavy structural load for residential, commercial, and industrial projects such as high-rise apartment, office, malls, hotel, factories, and power plant. By executing a systematic installation process, this engineering method successfully transfers immense building loads to deeper, stronger soil or rock layers, thereby reducing settlement and improving overall foundation stability. That's all from us. Thank you.